Okay, here we start a class now. The topic of the derivation is refraction. Refraction at a convex spherical surface. Okay. So this is for essay question, 5 marks derivation. I was just trying to check with the focus here. Okay, this is fine right now. Then let us see the diagram. Here is the refracting surface, which is convex. This is made of some material, glass, let us say, of higher density, higher refractive index mu2, surrounded by air of less refractive index mu1. So this is your principal axis. Let O be the object here. Keep in the air medium or denser medium. This is rarer medium. This is denser medium. Then this is the ray of light coming from the object. It is incident on the surface. After this will undergo refraction here. So O be the object and I will be the image. Then you need to draw another line which is perpendicular to the surface, that is called as the normal. So this will be your normal and this, let us call it. And from this point, let us say this point be A. From this point I draw another perpendicular line, let me call it as N here, and this point be called as the pole. P is the pole of the surface. So your object is here, O is the object and I is the image. So this point through which the normal passes, this will be called as center of curvature. So the corresponding angles are alpha, beta, let us call it beta, and this one is gamma here. And distance between the pole and the center of curvature we call as the radius of curvature r. And remember, all the measurements should be started from the pole, like PC, PO, PI, like that. O is the object, so object distance is U, and keep in mind the measurement should be like this. PO is equal to U here, measurement. And similarly, the measurement of the image is done from the pole, so this should be called as image distance, V here. Okay, this is the figure. Now let us come back to the diagram. Since this is the incident ray and this is the normal, this should be your angle of incidence I, and this should be your angle of refraction R here. So if you look at the triangle AOC, you can see I is the exterior angle. I am checking the focus. Okay, it's okay, fine. So I is the exterior angle. So how do you write this? Exterior angle is equal to the sum of the opposite interior angles. So it should be alpha plus gamma here. This is the first equation. And as we know that the assumption done here is all the angles whatever you find here, like alpha, beta, this alpha, beta, gamma and all these angles met with the principal axis. All these angles are very, very small. So as alpha and gamma, these are very small. This is the assumption. So because of this, you can write I is equal to tan alpha plus tan of gamma. Keep in mind, tan theta will be equivalent to theta only if theta is very, very small. Okay, theta tends to 0. So now this is your first equation. Then you go through the triangle again, tan alpha. Try to find out tan alpha again. Tan alpha you can see here. This will be equal to perpendicular by base. So perpendicular, try to take the measurement from the principal axis here. So let us take it as NA, perpendicular by base. The base should be this one, NO. As I said, try to do the measurement from the pole here, starting from the pole here like this, NI and NO in this way. So this is the one here. Plus, what about tan gamma? Gamma you can see in this triangle ANC. You can see gamma. So again, perpendicular is one NA again, and the base should be NC. Okay. Then Look at the figure again. Na divided by N and P are very very close, so you can take them as together. So instead of saying NO, you can say PO right now. So you can say PO plus Na divided by, instead of saying NC, you can say PC right now. Okay. So let this be the angle I here. Let us call equation number 1 here. I'm just checking. Okay, this is very difficult to record here. I cannot see what I'm recording right now. Okay, then after this, you try to find out from the another triangle again. That is here, another triangle ACI. At this ACI, exterior angle is gamma. So in the triangle, in this triangle here, ACI, the exterior angle is equal to the sum of the opposite interior angles. So you can write gamma is again equal to exterior angle is here. So interior angle should be R and beta. So you can write gamma is equal to R plus beta. This will give you R is equal to what? Gamma minus beta. As before, since all this angle alpha, beta, gamma are very very small, you can write tan gamma minus tan of beta one more time. So which is equal to tan gamma. Look at the figure again. Tan gamma. Gamma is here right now. So again, perpendicular is Na by base. Base is NC. Okay, perpendicular is Na and the base is what? NC. But as you know, P and N are very very close. So instead of writing NC, let me write directly as PC here. Okay, minus beta. Let us see again. Tan beta. Tan beta belongs to this what? This triangle here. So again, perpendicular in this triangle is Na again divided by base. The base here, the base is going to be Ni. But as I told you before, N and P are very very close. So instead of saying from N, you can say as Pi here. So Pi will be equivalent to V here. Oh sorry, V let us write later on. I'm just too advanced. So Na divided by, you can write as what? Pi. Let's say Pi here. Okay. So this much you have. And also here, one more thing. The Snell's law says that refractive index mu. Look at the figure. The light is traveling from first to the second medium. So you can write 1 to 2. This is equal to sine I divided by sine of R again. So which is equal to sine I. Instead of this sine I, you can put it directly, or you can do like this, or you can write here this portion mu 2 1. This can be written as mu 2 divided by mu 1. So you can write as mu 2 divided by mu 1 is equal to sine I divided by sine of R. Now cross multiply it, or again say mu 1 sine I is equal to mu 2 sine of R here. Okay, and as all these angles are small, again sine I can be written as also I again. So you can write, or again mu 1 I is equal to what? Mu 2 R here. Okay, so this is a very important relation we are getting right now. I'm just taking the focus here. Okay, let me continue the next page. So from here, you try to put in the value right now. I can write here mu 1 instead of I. You can write out this Na by PO plus Na by what? PC. Okay, is equal to mu 2 is written here, and R. Where is your R? R is here. It was equal to Na by PC minus Na by Pi. Okay, so Na all cancel one time here. You can write this Na all cancel now. Of course, you just multiply inside the bracket again, or you can write mu 1 by PO plus mu 1 by PC is equal to mu 2 by PC minus mu 2 by Pi. Right. Then let us use the sign convention. In sign convention, let us see what is this PO. Look at the figure here. PO stands for the object distance U. So this is going to be negative because the light is traveling from left to right. Left to right, you can see indicated by the arrow here. It's traveling from left to right, but you are taking the measurement as PO. This is from the rule of sign convention. You have to take the measurement from the pole here. So taking the measurement as PO, PO, it means you are measuring like this PO, which is against the incident ray. Incident ray goes from left to right, but you are measuring as PO against it. That's why PO means against the incident ray. So PO should be taken as minus here. Okay. And what about PI? PI, you can see here PI is like this. PI is done in the same direction of the incident ray. Incident ray is traveling from left to right. So you are taking as PI means the direction in which you are taking the measurement is in the same direction of the incident ray. That is why this is going to be positive here. Okay. So PI is going to be V. Alright. And what about PC? PC, you know from the diagram, PC is equal to what? The radius of curvature R, which is also positive again. So after this, you put now or mu 1 by, instead of PO, you can write, instead of PO, now you can write minus U here plus mu 1 by PC. Instead of PC, you can write R here is equal to mu 2 by PC is again R. Then what? Minus mu 2 by Pi is written as what? V here. Okay. So you can transfer now mu 2 minus U here plus mu 1. I'm writing here mu 1 by minus U plus, you bring it now, mu 2 by V is equal to, transfer here mu 2 R minus mu 1 by R. So all our final equation is, you can write here, or minus mu 1 by U plus mu 2 by V is equal to mu 2 minus mu 1 by R. I know I'm taking the class a bit faster because video will become very long and it's very difficult to send. Anyway, yesterday there was no electric power in my place. That's why I'm just conducting right now immediately. So I hope you can understand, and if you can understand also, keep on replaying the video